When we talk about a relation, we can talk about the domain and the range. So when we're talking about the domain, what that means is the domain is all of the inputs or the x values of the relation. So all the x coordinates of a set of ordered pairs, all of your inputs, it's the things you put into the relation. The range, on the other hand, is all of the outputs or the y values. So the y coordinates, the things you get back out of a relation, that's second coordinate. So we can talk about domain and range for both discrete graphs and for continuous graphs, and for discrete situations and continuous relations, and they look a little bit different, so we're going to take a look at that. When we are working with a discrete graph, a set of unconnected points, or with a mapping diagram, or with a set of ordered pairs, or with a table, something where they're discrete, which means separate, these separate points, we write our domain and range a certain way. We use curly braces to start, and the domain is the inputs, it's the x values. So we start by listing our x values from left to right, and we don't repeat any values, from smallest to biggest. So we start with -3, -1, +1, 3, 4, and 5. So even though there are 2 points that have 5 as the x-coordinate, we only need to write 5 once because we don't repeat any values when we're writing the domain or the range. The range is similar. We have the curly brace to open it, but now we're working with the outputs, or the y values, so we're looking at the y coordinates. Again, we're going from smallest to biggest, and we're not repeating any values. So we start with -4, -3, 0, 1, 2, and 4. So again, even though there are 2 points that have a y coordinate of 2, we only list 2 once in the range because we don't repeat any values. When we work with a continuous graph, and only a continuous graph, where we have these connected points, all of the numbers in between, all those infinite number of fractions, are also part of this graph. So we need to include them in our domain and range. So we need to use inequalities. We can use compound inequalities. And these are AND statements because we want things to be between one point and another. So again, with our domain, we're looking for the x values, our inputs, and we go from smallest to biggest. So our smallest x value is happening here, this line at -2. So we start with the -2. That is less than or equal to our x, which is less than or equal to our largest x value, which is happening over here at 5. So we have, for our domain, -2 is less than or equal to x, which is less than or equal to 5. We can work similarly with our range, except with the range, obviously we're looking at the y values, the outputs. So we look for our smallest y value, which is happening down here at -3. So we start with -3. That is less than or equal to y, because we're working with the range, so now we're talking about y, so we need to use a y. And that is less than or equal to our highest range value, which is up here at 4. So we get 4. So our range is -3 is less than or equal to y is less than or equal to 4. And that is the difference between discrete and continuous domain and range. So you want to watch out for how you write them. The only time you use inequalities is when you're working with a continuous graph. If you have a discrete graph or a mapping diagram or a table or a set of ordered pairs, you write it in this discrete fashion because they are separate, unconnected points. We don't know anything that's happening in between, so we can't include any of those fractions that are in between those points.